Today we are reviewing domain and range of relations. Let's first talk about different types of data. So discrete data is data that's not connected. We typically think of scatter plots as being discrete data. When we write discrete data, when we write domain and range of discrete data, we're going to use set notation. For set notation, we use the bracket, and then we have a number, and then a comma, and then another number, and a comma, and so on, until we've covered all the ordered pairs. So let's look at the domain. So which variable is the domain? It covers the x. So I'm going to go ahead and go along my x-axis, and I usually start at the left-hand side and move across. And that first x value is -6. Bracket, -6, comma. The next x value is -1. The next ordered pair, check that one, it has an x value of 3. And the last ordered pair crosses the x-axis at +7. And that's domain. Now let's look at the range. So the range goes with the y value. So the range here, I like to start at the bottom and put this so that it's in order. We're going to start down here, and it's -4. And go up, and this ordered pair crosses the y-axis, or excuse me, it has a y value of -2. The next one has a y value of 0, and then the one up here at the top has a y value of 6. And that's the domain and range for a scatter plot. Some people also like to take and write out the ordered pairs and list them. And then once the ordered pairs are listed, sometimes it's easier to find the domain and range from that ordered pair list. Okay, next I want to talk about continuous data. So continuous data is data that is connected. When we write domain and range for continuous data, we use inequalities. Second semester, we're going to show you how to use what's called interval notation, also to write the domain range for continuous data. But today we are going to use inequalities. So what I like to do is get a highlighter, colored pencil, something, marker, something, and box out the graph. Now, when I list out my domain, I'm going to go ahead and work from left to right. So starting all the way to the left, I notice that the furthest left this graph goes is -6. Now, we're going to use an inequality in here, and I have to decide what type of inequality. So I look at the endpoint. In this case, the endpoint is an open circle. So because it's an open circle, it's not inclusive. That means that this graph does not have a value at -6. It just gets really close to -6. So when we have not inclusive values like that, we're going to use a less than symbol for the inequality. Now because we're talking about domain, we're going to go ahead and put an X in there. Then we're going to go to the other side of the graph, all the way to the far right, and we have an endpoint here. And this endpoint, this value is at 7, +7. But I need to decide what type of inequality to put in there. So I look at the fact that I have a closed endpoint here, a solid endpoint. So that means that this 7 is inclusive in my domain. So I'm going to go ahead and put it equal to. So it's less than and equal to. So what this really means when we read this is x are all the values that are, -6 is less than x, but x is less than or equal to 7. So it's all the values between -6 and 7, but -6 is not included and 7 is included. Okay, let's take a look at the range. So the range is the y, so I'm going to move across from the bottom to the top. So down here at the bottom, I'm starting at -4. Now, even though we have this open circle that's not inclusive, notice that we have a horizontal line here, and that means we have actual values of that line that have y values of -4. So that's the one that we're going to work with. The fact that it's inclusive is more important than my open circle at the end. So this is going to become a less than or equal to. This time, because it's range, it's y. Then we're going to move to the very top. I see here this line, the end point up here, goes all the way up to +4. And it is a solid circle again, so it's less than or equal to +4. And there's your domain range. Let's go ahead and try example number 2. So example number 2, I'm going to go ahead and put a box around this. And I'm going to go ahead and move from left to right. So all the way to the left, I actually have an endpoint here that's arrow. So the arrow means it goes on forever. It goes on towards infinity. And because it's pointing to the left, the values on my number line that are going to the left are -infinity, the negative values. Now, we can never reach infinity, so that means that we are going to use a less than symbol that's not inclusive. So it's less than x because we're talking about domain. I go all the way to the right, and I see the end here, but again, I have an arrow, and my arrow, even though it's pointing down, is really pointing to the right. So that is also less than, and this time, though, it's going towards positive infinity because it's really pointing to the right towards all those positive values. For the range, I start at the bottom. Down here, again, I have this arrow, so we are going from -infinity, not inclusive. We're talking about the range, so it's a y value. And then we go to the top, and we do have a horizontal line at the top here. And because the other end is not pointing up, it's just pointing horizontal, that means we are going to go ahead and include these values. So it's less than or equal to +4. Okay, at this time, if in the case you talk about all real numbers, that would be written as -infinity is less than x, which is less than infinity. At this time, go ahead and pause the video, do the third example on your own, and when you're finished with this example, go ahead and turn the video back on and check your answer to see that you did it correctly. Okay, now that you've had time to try this third example, here we go. We're going to go ahead and box this out. For my domain, I'm going to go from left to right. So all the way to the left, I do have a closed endpoint there. So